This is a UTME problem on friction. And one general misconception about friction when solving problems on friction is the concept of normal reaction. The normal reaction. The idea of normal reaction is not necessarily that it is equal to the weight of the object. Normal is talking about perpendicular. When you hear normal, it's talking about perpendicular, that is making angle 90 degrees. Reaction is definitely from Newton's third law. When there is an action, there will be a reaction which is opposite. In this place, the action is against the wall. Therefore, the normal reaction is going out of this. As you are reacting with this F against the wall, the normal reaction is going out of this. So the normal reaction R is going against the force F that is applied on this body. And with that knowledge now, then we can begin to analyze this. From the question, it says that this block is of mass M held in equilibrium against a vertical wall by a horizontal force. If the coefficient of friction between the wall and the block is mu, the minimum value of the horizontal force is. Now let us analyze this. We take the horizontal component of the motion and we take the vertical component. Because they say that it is in equilibrium, means that the net force in this system will always be equal to 0, whether in the vertical direction or in the horizontal direction. Now for this first now, if I analyze the horizontal component of the motion, what you see here is that F is going to the right and R is going to the left, which means that F minus R will be equal to 0. The implication of this is that F equals R. I've mentioned why this will be equal to 0 because the system is in equilibrium. Now let's look at the second case. We have the weight of the object acting downward. And if this system is in equilibrium, that means that there is a form of frictional force going up like this. Because to know where the frictional force is going, let me call that F subscript R. Why did I say that the frictional force is going up? It is such that you need to look for the direction of motion. The direction of application of force is not the opposite direction that frictional force will act. Friction opposes motion and not necessarily the applied force. The net force acting in the system causes the motion, not the applied force. And you have to observe the direction of motion in this system before you can know the direction of frictional force. Hence, the direction of motion or the intending direction of motion for this object is downward. Therefore, the frictional force will be acting upward. Now, let us do the vertical component now. But since the system is held in equilibrium, that implies that the frictional force, which is up, minus mg, which is down, will also be equal to 0. Some people might prefer that the direction of motion, the intended direction of motion should be the positive side, which is mg minus fr. The reason why some people will prefer this is that so that when they want to, if there was acceleration now and they wanted to equate this to ma, they won't have to worry about this sign. Anyone you decide to do is okay. Therefore, this also implies that frictional force equals mg. And from what we know that the coefficient of friction is the ratio of the frictional force to that of the normal reaction. And with this now, we have the frictional force is mg, while the normal reaction, from what we have gotten here, is F itself. So the question asks us that what would be the minimum force that would keep this object in place. That means that we are solving for this F. If we can solve for F here, then we get our result. From this now, this implies that F equals mg divided by mu. And this will be the minimum force required to keep this object in place. If you would like to see more videos like this, don't forget to subscribe, like, and share. I'll see you in the next one.